The Voyager spacecrafts, humanity's greatest journey into the cosmos. Launched in 1977, NASA's twin Voyager spacecrafts, Voyager 1 and Voyager 2, embarked on an ambitious mission that would eventually make them the farthest human-made objects from Earth. These space probes have not only revolutionized our understanding of the outer planets in our solar system, but also provided unprecedented insights into interstellar space, the vast, unknown region beyond the influence of our Sun. As of today, the Voyagers continue their mission, offering humanity a unique perspective on the cosmos. This essay explores the history, accomplishments, and ongoing legacy of the Voyager spacecrafts. Origins of the Voyager program. The Voyager mission was conceived during the 1960s when scientists realized that a rare planetary alignment would occur in the late 1970s and early 1980s. This alignment, which happens only once every 175 years, would allow a spacecraft launched from Earth to visit the outer planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, by utilizing the gravity of each planet to slingshot from one to the next. This technique, known as a gravity assist, saves time and fuel, enabling a spacecraft to travel faster and farther than would otherwise be possible. Originally, the mission was planned under the name Grand Tour, but due to budget constraints, the program was scaled back and became the Voyager mission. However, the core objective remained the same: to explore the outer planets and their moons, rings, and magnetic fields. 2 spacecraft were built, each equipped with an array of scientific instruments to collect data about these distant worlds. The launch and early mission of Voyager 1 and 2. On August 20th, 1977, Voyager 2 was launched from Cape Canaveral, followed by Voyager 1 on September 5th, 1977. Despite being launched second, Voyager 1 was placed on a faster trajectory, allowing it to overtake Voyager 2 in just a few months. This is why Voyager 1 reached Jupiter and Saturn first, even though it launched later. Both spacecraft were equipped with instruments designed to study the planets they encountered, including Imaging Science System (ISS) to take pictures of planets and moons, magnetometers to measure magnetic fields, cosmic ray subsystems to detect cosmic rays, plasma detectors to study solar wind and plasma in space, infrared interferometer spectrometers to study planetary atmospheres and surfaces. In addition to their scientific payload, both Voyagers carried a unique artifact: the Golden Record, a 12-inch gold-plated copper disc containing sounds and images that portray the diversity of life and culture on Earth. The record includes greetings in 55 languages, music from different cultures, sounds of nature, and a message from then U.S. President Jimmy Carter. This record serves as a time capsule and a message to any potential extraterrestrial civilization that might encounter the spacecraft. The Jupiter encounter. Voyager 1 made its closest approach to Jupiter on March 5, 1979, followed by Voyager 2 on July 9, 1979. These flybys provided the first detailed images of the planet and its moons. Among the many groundbreaking discoveries were the Great Red Spot. Voyager's detailed images revealed that this massive storm, larger than Earth itself, has been raging for centuries. It also provided insight into Jupiter's turbulent atmosphere, with swirling clouds and lightning storms. Jupiter's moons. The Voyagers discovered volcanic activity on Io, one of Jupiter's moons, making it the first celestial body other than Earth where active volcanoes had been observed. They also provided new details about Europa, Ganymede, and Callisto, including evidence that Europa might harbor a subsurface ocean beneath its icy crust, sparking interest in its potential for life. Jupiter's rings. Before the Voyagers, scientists did not know that Jupiter had a ring system. Although faint compared to Saturn's, Jupiter's rings were a surprising discovery. The Saturn encounter. Following their success at Jupiter, both Voyagers continued to Saturn. Voyager 1 made its closest approach to Saturn on November 12, 1980, while Voyager 2 followed on August 25, 1981. The Saturn flybys were equally remarkable, yielding important discoveries about the planet, its rings, and moons. Voyager 1 revealed that Saturn's largest moon, Titan, has a thick atmosphere primarily composed of nitrogen, along with methane and other hydrocarbons. This thick atmosphere, obscured by orange clouds, was later studied in detail by the Cassini-Huygens mission, but Voyager provided the first evidence that Titan's atmosphere could have similarities to early Earth. The Voyagers captured unprecedented images of Saturn's ring system, uncovering the complex structure of the rings, including tiny spokes and the discovery that they are composed of ice particles. Voyager 1 discovered the Herschel crater on Saturn's moon Mimas, giving the moon a striking resemblance to the Death Star from Star Wars. After its Saturn encounter, Voyager 1's trajectory was directed out of the plane of the solar system, and it began its journey toward interstellar space. Meanwhile, Voyager 2 continued to Uranus and Neptune, the only spacecraft ever to visit these planets. The Uranus and Neptune flybys. Voyager 2 made its closest approach to Uranus on January 24, 1986, and to Neptune on August 25, 1989. These encounters were historic, as no other spacecraft had ever visited these distant planets. Voyager 2's discoveries were nothing short of extraordinary. Voyager 2 discovered 10 new moons orbiting Uranus and took the first close-up images of its rings. Beyond the planets, the interstellar mission. After completing their planetary flybys, both Voyagers entered what NASA called the Voyager Interstellar Mission, VIM. This phase of the mission focuses on studying the environment of interstellar space. The region beyond the influence of our Sun. Voyager 1 crossed the heliopause, the boundary where the Sun's influence ends, on August 25, 2012, making it the first human-made object to enter interstellar space. Voyager 2 followed, crossing the heliopause on November 5, 2018. In interstellar space, the Voyagers continue to send back valuable data. They are studying cosmic rays, magnetic fields, and the density of particles in this uncharted region. These observations have provided scientists with a clearer understanding of how our solar system interacts with the rest of the galaxy. Notably, the density of plasma, ionized gas, in interstellar space has been higher than expected, giving new insights into the nature of the interstellar medium. Longevity and power challenges. One of the most remarkable aspects of the Voyager mission is the longevity of the spacecraft. Originally designed to last only 5 years, they have continued to operate for over 4 decades. This is largely due to their radioisotope thermoelectric generators, RTGs, which convert the heat from decaying plutonium-238 into electricity. However, the power output from the RTGs decreases by about 4% each year, and as of 2025, the spacecrafts are operating on less than half of their original power. NASA engineers have been forced to make difficult decisions about which instruments to keep running. Some instruments have been turned off to conserve power, but both Voyagers remain capable of transmitting data back to Earth. It is expected that by the mid-2030s, the Voyagers will no longer have enough power to operate any instruments, and their communication with Earth will eventually cease. The legacy of the Voyager mission. The Voyager mission has been one of the most successful and groundbreaking space missions in history. The data collected by the spacecraft revolutionized our understanding of the outer planets and provided humanity with its first detailed look at many of the moons, rings, and atmospheres in the solar system. Beyond their scientific discoveries, the Voyagers have become symbols of human curiosity and exploration as they continue their journey into the unknown. The golden records carried aboard the Voyagers also serve as a reminder of the mission's broader purpose: to communicate the story of humanity to the cosmos. Though the chances of the records being found by an extraterrestrial civilization are astronomically small, they symbolize our desire to reach out beyond our world and connect with whatever might be out there. The Voyager spacecrafts have ventured farther than any other human-made objects, providing a wealth of scientific data and expanding our understanding of the solar system and beyond. Although their time is running out, their legacy will endure, reminding future generations of the power of exploration and the vastness of the universe. Their journey, while far from over, stands as one of the greatest achievements in the history of space exploration.